This calculation is for N5 Electrotechnics. It is still DC machines, which makes up 20% of the curriculum. Now we'll be looking at example 1.2 from our textbook on page 7. And just a reminder again of the EMF equation. To calculate the EMF, it is the generated EMF in volts, small letter P, number of pole pairs, C is the number of parallel paths. If it's wave wound, C is equal to 2. If it's lap wound, C is equal to 2 times the number of pole pairs. The flux measured in Weber. Z is the total number of armature conductors. N is the speed in revolutions per minute. Now in example 1.2, the armature of a 6-pole, 25 kilowatt, 500 volt series motor is wave wound and has a total of 60 armature slots. The motor operates at a full load efficiency of 92% while running at 1,100 revs per minute. The resistances of the armature and series fields are 0.2 ohms and 0.15 ohms respectively. Calculate the possible number of armature conductors per slot if the useful flux per pole is 45 milliwebre and the total brush contact resistance is 0.2 ohms. So first of all, for N5, always draw your diagram first. So first of all, this is a motor. Let's just make a note to ourselves that it is a motor. Therefore, it is drawing current from the supply. The current passes through the series winding, so we'll call that ISC. And then the current passes through the armature assembly. Now, for a motor, it is mechanical out and electrical in. We need some voltage across our terminals in order for the circuit to operate. It is the armature assembly that produces the EMF. And let's just write down all the information given. So first of all, the efficiency is 92%. So therefore, to calculate the input power, it will be the output power of 25,000 watts divided by the efficiency of 0.92. So therefore, the input power will be 27,174 watts. Okay. Now, first of all, we're going to calculate the supply current in order to work out the possible number of armature conductors per slot. I'm first going to calculate the supply current. In a series circuit, just important to note that IL is equal to IA, which is equal to ISC. It is a series circuit. So to calculate the supply current, it will be the input power divided by the terminal voltage. So therefore, the input power is the bigger power. It's going to be 27,174 watts divided by the terminal voltage of 500 volts. And therefore, the supply current is equal to 54,348 amperes. Right, now that we've got the supply current, we can actually calculate the back EMF. This is a series circuit, so there's multiple volt drops. We have the terminal voltage. It's a motor, so it's minus IARA minus ISCRSC. And then we have the volt drop for the brushes, so that's going to be IA times the resistance of the brush. Okay, so you can see there's a couple of volt drops there. Now, just to note that current stays the same in series, so that's a common factor. So just using a little bit of mathematics, our terminal voltage is 500 minus the current is 54,348, and then we will have all our resistances left behind. So we have the armature and series field resistances of 0.2 ohms and 0.15 ohms. And then they've given us some additional information here. The brush contact resistance of 0.2 ohms. So that's what's going to be inside the bracket. And we can use our calculator and we find that the back EMF is going to be 470,109 volts. Right, now we can actually answer the question. The question wants to know the possible number of armature conductors per slot if there are 60 slots. Right, so here we're going to use the EMF equation to work out Z first. So it's 2 times pole pairs times the speed in revs per minute times Z times the flux in Weber all over C, which is the parallel paths, times 60. So we need to calculate Z. So to calculate the total number of armature conductors, it will be the EMF times the parallel paths times 60 all over 2 times small letter p times the speed times flux per pole. Right, we can substitute all that in there. The EMF, we just worked that out. It is 470,109. It is wave wound, therefore C is equal to 2 times 60. All right, 2 times. This is a 6-pole machine, so therefore there are 3 pairs. The speed measured in revolutions per minute is 1,100. And the flux per pole measured in Weber. Now to convert milliweber to Weber, it will be 45 times 10 to the power of minus 3. Therefore, the total number of armature conductors is going to be 189,943. If you want, you can just put conductors there for some units. All right, now to actually answer the question finally. Okay, so to calculate the number of conductors per slot. All right, let me just see if I can squeeze this in here. To calculate the number of conductors per slot, it'll be Z divided by the number of slots, and the number of slots was 60. So we take the total number of conductors divided by the number of slots, and we get 3,166. Now we round this up. You can't have a small piece of a slot or small piece of a conductor per slot. So therefore we have 4 conductors per slot. Right, thanks for watching this video for N5 Electrotechnics.